Yichen, you got a 31, not 28.
Sorry, the question 28. The question.
Whiteboard. Oh. But it
Oh,
shows that no one
谢谢。
got the question 28 correct somehow. That's what it says. Hmm. So let's go over the problem.
Okay, so does anyone want to do question 21?
Oh, Gilbert, you need to start the recording.
I
It's,
already did.
oh, really? Oh, yeah. Oh, thank you. Oh, Gilbert, you can start like if no one can answer this question, you can, yeah, you can show people the procedure, the solution.
So is no one answering 21?
Mm, yeah, later you can do the code call, but for every time when you present a problem, a solution, you need
Okay,
to copy paste the problem first to let
okay.
people know what
I
which
guess
problem
we're
you're
just
working on.
I guess we're doing number 21. So hold up. Let me just
Mm.
screenshot real quick. I mean, like, screenshotting. Let me just upload this.
You can just screenshot and drag it to the whiteboard.
Wait a sec.
Or
Documents,
you
desktop.
can ask somebody else like Edward or each and help you to do the screenshot.
I don't really need help. And why the hell do MacBooks like prioritize applications over files? Anyways, let me just
Mm.
wait. It's so like let me try wait, is it on does it go to desktop? Oh, it does.
Yeah, the screenshot is always on
Okay.
desktop. Yeah.
So like anyways, we see like let's just say that AT equals 2. So like these are equal to like 1. And we realize that this is 30 degrees. So like this is root 3 over 3. And and we also see that this is we see like 30, 60, 90 everywhere. So this is root 3. And this is 2 roots 3 over 3. And and like this is also like root 3 over 3 because of symmetry. And so is this lower one here. By the way, this is like the distance between like
Oh,
if
Gilbert,
these
because you zoomed in this picture, like so people cannot see the
okay,
given
so
condition.
this is like
Yeah.
1 and 1. So So then TH is just equal to MA, which is like 2 plus 4, 3, mm, 3, and we need to divide it by 2. Okay, and if we, let me just move it to the numerator, so this becomes a 6. And if we divide by 2, we get 3 plus 2 root 3 over 3. So yeah, okay. So next problem. Okay, so did you all get that? Okay, then next problem, number 22. Wait, wait. So let me just upload it here. Does anyone want to do this question?
Or Gilbert, you can start like a, introducing your method, and probably in the middle you can let other students to pick up from
So,
there to
okay,
see
so
if they
like
can continue
here
with
we
the
realize,
solution.
that three or fewer digits, that means like we can just considering them with leading zeros, but like they're like positive integers, so like this can't be 000. It actually starts from 001. But 001, like 000, the cubes of the digits don't sum to 100. So for convenience sake, we can just like ignore the fact that it's positive because 000 doesn't contribute to the answer. So like we use complementary counting to find when the cubes of their digits don't sum to at least 100. And like the smallest cubes are like 64, 27, 8, and 1. So that we see on, okay, oh shoot, low battery. Well, I guess I'm just gonna finish this question. So like we see that when the digits are zero, all 0 to 3, then there won't be any issue. Then it won't sum to at least 100. So for 64 cases, and like then the slightly tricky part is when there's a 4 in the digits. So like there's a 64, and then and they accept the way that, and to make it not sum to at least 100, then the sum of the digits can be 64, 27, 8, or 64, 8, 4, and all less than 27. So yeah. And in this case, there's like 3 cases for which position the 4 is in. And by the way, 4 cubed is 64. Oh yeah, there's also 64, 27. Okay, it's more generally 64, 27 less than or equal to 8. There's 2 cases for where the 3 goes. 3 cubed is 27. And then there's 3 cases for the remaining digit, which is 2, 1, or 0, for 18 cases to exclude from the answer. And here there's 3 cases. And for the other numbers, there's like three possibilities for each one. So 3 by 3 by 3 equals 27. And in total, we have excluded 109 cases. So our final answer is 891. And let me just double check that this agrees with the answer key. So this is right. Now for question number 23. Let me just, okay. So does anyone want to volunteer to do this question? Okay. So I guess I'm just going to do it one last time before I cold call. Okay, so like we realized that since the sum of the three numbers along each side are the same, the sums of all of these three sums must be a multiple of three, and the the ones that are not at the corners are each counted once, and the ones that are at the corners are counted twice. So the sum of the numbers at the corners and the numbers not at the corners must each be a multiple of three. So after some fiddling around, we get that 0, 1 for the numbers at the corners, like these are the only possibilities. 0/2/4 and 1/3/5. And like for this case, we do like you put like the 3 in here, the 4 in here, and the 5 in there. And like the other cases, we kind of just do that as well. So there's like a total of 4 cases. So yeah. And now for question number 24. Hold up. Let me just do this real quick. And okay, so let me volunteer Vincent to do this question. Hello.
Uh, wait, I didn't solve this.
Oh,
Yeah, let
okay.
each and with an Edward or somebody else try it.
I guess I'll let
Or Om. Did Om do it?
I'll guess I'll let Owen solve this question. So you may present.
So, basically, wait, do I like present? Oh, wait, am I like presenting now? So like the LCM times the GCD is equal to A times B, and then you want them like the sum to also be the same. So like obviously that can be possible if the LCM is like is equal to either A or B, and then GCD is equal to the other one. So you could have, so the only way that's possible is if the LCM is like, let's say A and the GCD is B. So then the B would have to be a factor of A, because then the GCD would be B and the LCM would be A. Or it could be the other way around. So if B is like 1, then there's 45 ways. And if B is 2, then there's 22 ways. And then like you just keep going until you have like B equals 45. And then you can like make it faster by like figuring out like, because you need to figure out how many multiples of like 2 or like of B are like from 1 to 45. So you can like make it faster by figuring out counting multiples, and then you just like keep going, and then you add it, and I think you get like 182, and then you have to multiply by 2 and then subtract 45 when A and B are the same, because that's double counted. And this thing divided by the total is 2025. So you get 319 over 2025.
Okay. Yeah, like that's how I did it too. So, yeah. Okay, so now let me put up question number 25. And okay, How about I let Edward solve this? Oh, okay, let me think. Did any, did, an- there's actually like wait, I guess that I'm just going to present it then. So like, ah, I don't know. Okay. So you basically realize that x equals negative k works because when you plug it in, everything cancels and it's 0. Anyways, and then like we just and okay. Anyways, like let me I don't know about the quadra. I mean, it's kind of a fake solve, but like so you just do the sum forever and you use this theory. I mean formula to get this. X equals negative k. Oh, like you just plug it in, so like you get k squared minus k squared plus 1. Wait, plus 1 equals 0. And Vincent just asked about number 23. Let me just see. Oh, I don't know how you really do it for certain. You just like test cases and with the fact that like the sum of all the numbers in the corners or not the corners must be a multiple of 3. And like yeah. Now, does anyone want to do question 26? Hold up. Wait. So I don't how about I ask hmm did did Ohm solve this one? What about Edward? Okay, I guess wait, Vincent solved it. Okay, I guess I'll let Vincent present then.
Okay, so I did a really bad method, but it's fine. This is 2, this is 3. Oh shoot. And then you get that the cosine of this angle is 3 root 13. Oh my God. 3 root 13 over 2. Or wait, no, what am I doing? It's 3 over root 13. And then the sine is like 2 over root 13. Oh my God. And then you can take the cosine of this angle using the cosine double angle. And then you do that and get 5 over 13. Um, and then this the sine of this angle is the double cosine of this angle because they're complementary. So the sine of this angle is 5 over 13. So this is a 5, 12, 13 triangle. And you know this is 5. So then this is 25 over 12. And then this is 35 over 12. I think that's what I got.
Okay. So wait, where's is 35 over 12? Okay. So now we'll go to question number 27. Hmm. So I'm just gonna do this again.
Oh, Edward,
Hmm.
next time you don't have to delete the previous solution or the previous problem. You just scroll down and just write down just like writing an
Okay.
assignment. Yeah.
Excuse me, you said my name wrong.
Oh, Gilbert. Yeah, yeah. Gilbert. Yeah.
Anyways,
Uh-huh.
so
Yeah, you don't have to delete the solutions and the problem. Yeah.
how about I ask
Just scroll
Ed,
down and find a space to
hmm,
write another problem. Yeah.
how about I ask, did Edward solve this one? Why you? 'Cause why not? I mean, if you did it, then present. You didn't do it? Oh, I guess I'll let Vincent present again.
Okay. Wait, what I did was like, you combine these two terms, and then you get like r squared as I can't write, plus s squared r plus r squared plus s squared, um, squared over rs plus r plus s plus 1.
What?
And then this is calculable using Vietas. This is just r plus s times rs. And these are also direct applications of Vieta. And then you get like negative 108 plus r plus s squared, which is 81, minus 2rs over the bottom, which is just 12 minus 9 plus 1, which is 4, and then you calculate this and you get hold up, let me check. You calculate this and get negative 51 over 4.
Negative 51 over 4. Anyways, okay, for now, let me just go and get number 28 real quick. And oops. Okay, so like this one, I guess I'll let Yi Chen present.
What?
I'm letting you present question 28.
Okay. So, this is conditional probability, which is the worst topic in combo. So I guess we just do it. So total amount of cases, we have 3 to the 100th power, right? And then we can consider each element here. So each element here is either in A, B, or A and B. So then what we want here is the union of A and B has three elements. So that means three elements are in A plus B, and the other 97 elements are all in either A or either only A or only B. So that means that totally our number of cases is that here we have two cases and that's one. So three of this and 97 of this. So it's going to be 2 to the 97th power times three, no, one to the third power times 100 choose three. And if you evaluate this out, this is like 2 to the 99, 5 squared, 7 squared, 11 to the 1, over like 3 to the power of, I think it was like 99. But that's irrelevant. So the top, which is M, just has 100 times 3 times 3 times 2, which is 1800 positive factors.
Okay, so that's the solution. And now for question 29, I'm going to present. Let me just screenshot it real quick. Okay. So so this is like we basically kind of do a telescoping, and so like it's like a product of a lot of fraction of the term n squared times n plus 1 squared. I mean, n plus 1 factorial. Let me just zoom in. Plus n plus 2 factorial. So like over n factorial. Wait, this is a plus. Let me just delete that little sim. Oops. I think it's better. Let me just redo that part. Plus. Wait, this is a minus 3 n plus 1 factorial. And let me just finish writing this. And so you basically then divide the entire thing by n factorial to get 1 plus n plus 1 plus n times 2 times n plus 1. I mean, n plus 2 times n plus 1 plus n squared plus 3n plus 2 over 1 minus 3n minus 3 plus n squared 3n plus 2. And it simplifies to n squared plus 4n plus 4 over n squared, which is just n plus 2 squared over n squared. And there's multiple of these terms, so we just do telescoping like this. 4 squared over 2 squared times 99 squared, 98 squared, 100 squared over 99 squared. And all of these cancel, so it's just 99 squared times 100 squared over 4. Hold up. Yeah, the answer key seems about right. So like, yeah. And then we eventually do arithmetic to get 9/8 go ones by 2500 equals 2450 2500. Let me do. And yeah, that's the answer. Is anyone confused? If not, then I guess we'll go to question number 30. Oops, I get. Never mind. So, does anyone want does anyone want to do question 30? Um, okay. If no one's volunteering, I guess doing it again. They're like the number of candies. It's like a 1/3. And I know of a fake solve way, but let me just try to do a real solve on the spot. So like let P of n be the probability of dispensing n candies. So P of n equals 2/5 P of n minus 1 plus 3/5 P of n plus 1. And like P of n plus 1 would just be, and we can just move like the factors of 5 all to this side. Okay. Let P of 1 be
Oh,
A.
Gilbert, you need to let people follow you. Somehow we can only see part of the solution.
Okay, here.
Mm.
And I already wait, let me think of if there's like a way to make this easier. And wait, we're not presenting number 27.
Oh, so you guys are presenting question 30, right?
Yeah.
But it's not recorded because you didn't choose certain button to let people follow you.
Okay, I
So the
guess.
page got stuck over here. Yeah. Yeah, that's correct. Yeah.
Okay. Wait a sec. When you're presenting, the edit bar doesn't appear, unfortunately.
You don't have to present it. You just choose everybody follow you.
So,
It's on the top right corner. There's some button you can do. Let everyone follow you. Can you find? Yeah.
so like, let me just see here. And like, anyways, my fake solve way is just to like multiply by 2/3 all the way through. I mean, and if anyone wants to build on like the formulas I already got to like try to attempt a real solve, they're very welcome to. And you realize, and just to verify that this satisfy the formula, then like, And if we substitute, we get this. So like, yeah. And by the way, wait, 16 over 3, oops. It's supposed to be this. So like, yeah, that's the answer. And if anyone wants to attempt a real solve, then they're welcome to. Or should we just go straight to target? Hmm. Okay, then. I guess we're just going straight to target now. Let me just get problem 6 real quick. And upload this. Did Vincent do this? Hmm. Okay, I guess I'll just let Edward present. Oh,
I didn't do this question.
oh. Okay. I guess I'll just present again. I did kind of a bashy way. So like the probability so like there's several ways. So there's 4 to 3, 4 to 1, 4 to 0. And if the game ever reaches 3 to 3, it's a deuce. Okay. So from 4 to 2, like we know that the last win must be Jason's because then or else Jason would have won er, the last game must be Jason win because or else it wouldn't be 4 to 2, it would be 4 to 1 or 4 to 0. So it's at so it's like 5 choose 2 for the 2 times Kenny wins times 0.7 to the power of 4 times 0.3 squared. Hmm. So like let me just plug this in to quickly get 21.609%. And in the for one case, 4 choose 1 times 0.7 cubed. No, it's still to the 4 times 0.3 equals 28.812%. And 4 is just 0.7 to the 4, which is 24.01%. And like the chance of even And for the deuce one, it's slightly more complicated, so the chance of reaching the deuce is 6 to 3 times 0.7 cubed times 0.3 cubed equals 18.522%. So, okay, so let's say we're currently in a deuce. So like after two more points, then either someone will have won or the deuce will continue. So like let's say a deuce, there's like a 0.7 squared or 49% chance that Jason wins after two turns, and a 9%, which is zero point 0.3 squared chance that Kenny wins, and a 42% chance that it's a deuce again. And the chance that Jason will eventually win, given the game reaches a deuce, is like 49% over 49% plus 9%, which just, and then we multiply that by the chance we even got a deuce in the first place. Um, it's 15.648%. And the total probability, okay. And by the way, the total probability, we get 21.609. And just let me just section this off like this. I mean, in my work, I like to section them off like that. I'll just section off the 18.522 because it's not a partial probability that Jason wins, but rather the chance it reaches a deuce, so we don't add that. And we add all of the partial probabilities. Is that even a word? 22 8.812 plus 24.01 plus 15.648. And we round it off to get a final answer of 90.08% chance that Jason wins. Okay. So, yeah, that's it. So now let me just get number 8. And for number 8, I will ask Yi Chen to present. Um, did you even do it? Are you there, Yi Chen? Wait, you're over here. Is that a yes or a no? Well, do I just present then? Okay, the decision is that I'm gonna present. Okay, so from here, from power of a point, we can see that. Oh, you left your room for 30 seconds. Okay, I guess you can present then. Nah, it's fine. Okay, I guess I will present. So, power of a point. So, okay, so let these intersection points be D and E. So we know that AE squared equals AX times AY. So AE equals 2 root 30. And similarly, from power of a point, we get BT equals, yeah, like, oh, right, 4 root 15. So let the radius of the circle be R, and since it's a right angle, these are also R. And I don't know, I don't think it's the best way to do this, but I just use a rather bashy quadratic formula way. R plus 2 root 30 squared equals, if you have a calculator, yeah, you're allowed to use calculators on target rounds. So equals, oh, plug in equations. I mean, quadratic formula is still fine to an extent. Equals 30 squared. R squared plus 8 root 15 plus 8 root 15 R, I mean, plus 120 plus R squared plus 4 root 30 R. Graphing calculators, I don't think are allowed. 240 equals 900. They are rules. I mean, then we get 2R squared. Okay, bro. I mean, I never really knew that. Memory cleared. I mean, yeah, of course, because like you can just put cheating on the memory. And then we use quadratic formula. And since we want our answer to be positive, we use the plus root. Okay, hold up. Let me double check. And we get an answer of like approximately 7.86834. One nine. And you can just save it to a variable, so like it makes things much easier. And we get that, okay, we get that the area is just 1/2 base times height. Area equals 1/2 BH. No, 1/2 R plus 2√30. R plus 2√15. I mean 4√15 equals equals 219.85. And just for the sake of it, I'll put units. So yeah, this is the final answer. Well, I guess we're done. So can we all just leave?
Oh, no, 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 don't leave, don't leave right now. Oh, I'm going to make an announcement, okay? Next week, I know it's spring break, right? You guys gonna like relax a little bit, but don't relax too much, okay? Because at the end of the spring break, we will have the chapter round. Chapter round held in at I think on Saturday. Yeah, at a Harker Middle School campus. So yeah, so during the spring break, we're gonna spend 2 hours, working on another mass count national round. Yeah, national exams. And the OM gonna be the host. So make sure you mark your calendar and reserve time for this practice. Okay.
Oh,
Uh,
what day and time again?
you mean what day? Still on Wednesday? On Wednesday night,
And
7 p.m., starting at 7 p.m.
and
as
you're gonna
usual.
like
Yeah.
send an email anyway, so
Yeah,
like
I will. I will send an email, the link, and also the answer sheet. Yeah, the answer sheet to collect the Google form to collect your guys' answers. Yeah, just like what we do all the time. Yeah. So, but I'm not sure if you guys gonna travel or not, but yeah, leave the Wednesday night available for the training session, okay? So, uh, okay. So see you guys next week. Later I'm gonna send the video, send the recording to you guys. Oh, so Gilbert, don't forget to upload the recording. You didn't stop recording. You're still recording. So just upload the recording to the cloud. Okay. Thank you so much. Thank you, Gilbert, and thank you everyone for coming to this, yeah, practice session.